All right, hello everyone. Thank you for tuning in to this week's Corundum developer meeting. Let's go ahead and get started. I'll just go over a couple of quick announcements real quick and then get into the status updates. So let's see. For announcements, the next meetings are going to be as scheduled. The next Corundum developer meeting will be on May 8th in 2 weeks, and the next Switch developer meeting will be next week on May 1st. Yeah, and then the upstream Corundum Git repository has also been updated, so you can go ahead and take a look at that and make sure it doesn't break anything. If anything weird's going on, please let me know, and I'll take a look at it. But yeah, so this just got a copy of more or less the latest code that was over on the sysnet repository. All right. So moving on to status updates, we got checking in on the FIFO memory inference issue with a couple updates on that. And then I've also been doing some work on device support, so got a few words to say about that, and then just another overview of the new queue management stuff that I'm going to be working on next. I don't have all that many status updates this week because, well, jury duty, I didn't get a lot done last week. So, all right, let's get into this here. So the FIFO memory inference issue, I've gone over kind of the background on this a few times, where Quartus is not handling MLabs properly in certain cases, and this is producing some unexpected behavior. So the folks at MLE were seeing transmit packets with incorrect IP layer checksums, and what I've been seeing with my testing is hardware checksum failure messages on RX, but only on Intel devices. I think it basically applies to all of the currently supported Intel boards with Corundum, but none of the Xilinx ones. So MLE traced the problem to the FIFO between the TX engine and TX checksum compute block that was incorrectly setting the enable bit and causing the screwed up checksums. So it appears to be something going on with Quartus. They reported it to Intel. And then we actually have a link here to an article on the Intel site referencing the issue, and it seems like it has something to do with the MLabs not supporting output registers, so they infer a latch, and then they don't properly perform timing analysis on said latch, so there's setup and hold issues that prevent things from working correctly. So yeah, that's not great. Who knows when it's going to be fixed? They said it's scheduled to be fixed in a future release. It's not fixed as of 23.1. I tested it. I was getting the hardware checksum failure messages. So, yeah. But I went ahead and took a look at doing a workaround, because it seems like it only affects the FIFO modules, even though there's a few other things that use the MLabs. It seems like if you apply a workaround to the FIFOs, at least I haven't noticed any other problems. So may or may not be a complete fix, but seems like forcing the FIFO RAM into M20K blocks resolves the problem. I guess there was a couple of different potential workarounds. One of them was to add some sort of a synthesis keep or preserve attribute on the output register. Another possibility was to force the blocks into M20K. It seems like they both more or less accomplish the same thing, at least according to looking at the build information in Quartus. So if you add that preserve constraint, then Quartus reports that it's using M20Ks for those RAMs. So I went ahead and went with the setting the RAM style to force M20K inference. But instead of implementing the workaround upstream in the AXI stream repository, what I did instead is made a copy of the FIFO module in all of the Intel targets that are affected by this problem. So that local copy has the RAM style set. And then once the issue is resolved, we can remove that that modification. Another thing that I'm considering doing is apparently the Verilog attributes can be set from parameters. So it might make sense to expose some of this stuff as parameters that you can modify. Like if you want to force, if you want to have a FIFO, use URAM versus block RAM versus M20Ks or whatever, we could potentially expose that as a parameter you can set on a per instance basis. I'm not sure if that would apply well to this bug or not, and it also would start bringing in some platform dependent stuff, but potentially something to consider. Having a RAM style option you can set on a per instance basis on the FIFO module. Just something I was thinking about recently. Might make sense to implement something like that. But this seems to work for, I don't know if I've tested all of the boards, but I've tested a few of them, and it definitely seems to help quite a bit. I've also done a little bit of work on adding support for a couple of different devices. I've had an Agilex F dev kit lying around for a while. It was in the lab for a while. I finally went and picked it up. So this one is very similar to the DE10 Agilex design. Had to make a few modifications to make it work, including I had the board gave me a real runaround because I accidentally screwed up a pin assignment, and as a result was getting a very strange message when I tried to load the design on the FPGA because it wasn't getting a clock that it was looking for. Yeah, basically, if you don't have all of the clocks running, all the reference clocks for the E-tiles, the FPGA design won't even load on the FPGA. Configuration will fail, and it will give you a very cryptic error message. TIL, kind of annoying. Anyway, we now have 25 gig and 100 gig designs for the Agilex F dev kit. So that's in the repository, that's live, they seem to work. I guess another couple of minor things about that board. They have EEPROMs as far as I can tell, and I do have the driver code set up to read those EEPROMs, but they're blank. So that's the same situation as a number of other dev kits where technically they can support persistent MAC addresses, but they don't have one programmed. And then the other aspect is that the transceiver interfacing, they use the mod cell pins. So currently we can't talk to the transceivers via I2C, which is annoying, but what are you going to do? Let's see. And then the Stratix 10 DX dev kit, it seems like Cord has finally fixed the 100G E-tile setup on Stratix 10 DX. I tried to put this design together a while ago, but it wasn't. I can't remember what issue I was running into. I think it wasn't building for some reason in Quartus. But that seems to be fixed now. It builds and it runs at 100 gigs. So I went ahead and got that committed as well. The other thing I had to do is on this board, the module control pins are driven by this FPC202 chip, which does a couple things. It kind of acts like a GPIO expander over I2C. It also acts like an LED driver. It can do some blinking and PWM things. And it can also, does like address translation for I2 for the module addresses that sit behind the devices. They got a bunch of features, but I finally managed to figure out what addresses you got to poke to talk to the transceivers, and also to control the I2C module control pins, because you have to flip the LP mode pin in order for optical modules to work correctly. And annoyingly enough, there's something weird going on with the equalization on the E-tiles, and at 100 gig, they don't seem to initialize all the equalization properly. So they only really work with the, AOC optical cables. Well, or I guess anything that has a CDR in the transceiver. So you have to flip the LP mode pin for those to work. So I managed to get that set up in the driver, so that works. And that means the 100 gig design on the Stratix 10 DX dev kit works. So that's about all I have to say with regards to that. But yeah, those are now live in the mainline repository along with everything else. I also made a couple other minor changes when I was poking around with the Intel devices. I was running into some hangs. Partially, this was a result, I think, of the FIFO memory inference issue, but even after fixing that, it wasn't completely solved. So I increased the size of the event FIFOs to at least reduce the probability of events getting lost. And that definitely seems to help on the Intel devices. The Silence devices, for whatever reason, I haven't had an issue with this. I'm not sure why. It might have something to do with how the PCI Express interface is set up on, Intel versus Xilinx devices. But that definitely helps the setup there. I also renamed a couple things. The Intel dev kits, I renamed those folders based on the part number. And then I also dropped the part suffix for non-ES parts. So like the E10 Agilex, the board that I have has an ES FPGA on it, versus the production one has a different part. So previously I had them annotated as 24AR0 and 24B. Well, I just dropped the 24B suffix. So there's just FPGA and FPGA 100G, and then on FPGA 25G or whatever the those subdirectories are. And then I have the AR0 ones for the ES part, and it's a similar story for the Agilex F dev kit as well. So you can still build it for one part or the other. I'm just making it a little bit more clear, which ones are production and which ones are ES parts. Slightly different story for like I think it was a Stratix 10 MX dev kit, where it comes with two different production parts. The difference is the size of the HBM on the part. So for that one, they're both annotated, so you make sure you build the right one. Okay, so I think that's about it in terms of kind of updates to the repository and whatnot. Like I said, it's been the mainline repository has been updated with the latest version of the code at this point. I've been trying to backport a lot of the changes I've made. So most of the interfaces and whatnot are, there haven't been any major changes to those. But going forward, I am going to be making some changes to the queue management logic and a few other things that are going to be breaking changes. So, I'll definitely let you guys know when these are going to be hitting the main repo. I think there was a version number bump associated with the descriptor changes, the addition of the phase tag bit. So it's backwards compatible, as in you can run an older driver with the newer hardware. But if you're looking for the phase tag bit, then you'll want to check that version number to make sure you're using the latest version. All right, let's see. So getting back to the queue management stuff, this is what I'm going to be working on next. Basically, there's a couple of things that I'm trying to accomplish with the reworking of the queues, and partially this is to to support the newer queue management logic that I'm going to be working on. And the newer queue management stuff, I'm mainly talking about the descriptor fetch and completion write back stuff. Because one of the issues, the last time I took a crack at implementing that, I was running into some issues with sharing the queue state logic across different types of queues. So at that point, I just kind of punted on it, but now I kind of rethought what I should do there. And I think it's going to make more sense just to kind of separate everything. And instead of having, and to try to consolidate the queue types. So instead of having a whole bunch of different types of queues, if we can consolidate that down to, fewer and support, dynamic allocation and whatnot a little bit better, then I think that's going to be, a more useful setup going forward. So instead of having TX queues, RX queues, TX completion, RX completion, and event queues, we're going to combine the TX and RX completion queues into a single completion queue type. And then for the TX and RX queues, what I think I'm going to do is move to having queue pairs, which is a combination of a send queue and a receive queue. So I think this is going to make a lot of sense going forward, because at some point it would be nice to be able to support RDMA. So if we actually support, kind of a queue pair primitive in hardware, could make things a little bit more straightforward. And then I think it also makes a little bit more sense in terms of just an FPGA logic resource utilization perspective. We can store, I think, the combined send queue and receive queue pairs more efficiently in RAM on the FPGA. Another thing that I've been looking at is, how to do dynamic allocation of queues, because I think this is going to be something that's going to make things a lot easier. I think it's going to be required for RDMA, because you're going to have software allocating however many queues at once. But I think it's also going to be necessary for supporting SRIOV, where you might have multiple virtual functions, and each one is going to get some subset of the queues. They're not necessarily going to be contiguous or whatever, so things are going to have to be a little bit more flexible. I've already made a couple changes kind of in support of some of these modifications. On the RX side, I've gone ahead and added an indirection table for RSS to work correctly. I guess I should have mentioned that as well. With the latest version of the code in the mainline repository, I do have the RSS table present. So you may need to make a couple modifications to initialize the RSS table if you have a user space driver or something, if you're going to try out that code. Otherwise, the everything might just end up on Q0, because I think coming out of FPGA being configured, the whole RSS table is filled with zeros. But yeah, the idea with the RSS table is then you can allocate whatever queues that you want. They don't have to be adjacent, and then you can just program the indirection table accordingly, and it'll figure it out basically. The other thing that I think I'm going to do is separate the completion and event write logic, because for the events, we might not want to do any kind of batched write back with those, because we're probably only going to get relatively small number of events. We want to get those fired off ASAP. We are going to be doing coalescing on the completion generation, so I don't think it really makes sense to do kind of two levels of coalescing where we have that both on the completions and on the events. And then also, if we separate that, then it means we can have two different completion write back modules. One of them a much simpler one for the events, and then a much more complicated one for the completions. And this was another thing that I was thinking about too, is that with the batch completion write back, we don't want to evict stuff and force writes unnecessarily. So if we keep the events separate, then the event write back won't be evicting the completion write back. So we can potentially do more batching where it's more useful on the completions. So I'm going to be taking a look at this over the next week or two. All right, so one thing that I've been looking at as well as part of this is how to store the state in the FPGA. So the current way this is set up is that it looks like this. In URAM, we have 64 bits for the base address per queue, and then we have basically another 64 bits for the producer consumer pointers and the CQ, EQ, or IRQ index, depending on what kind of queue type we're looking at, along with the queue size and a few other things. So this fits nicely into two URAMs. You can fit 4096 queues into two URAMs. So more or less, we're going to keep something similar for the completion and event queue state, but with the TX and RX, that's going to be modified a bit. So with the new setup, we're looking at doing queue pairs. We're going to shrink down the size of the base address register here, force 4K alignment, but in doing so, we can use those bits for something else. We'll add a VF index field for everything. And then on the queue pair side, we're basically going to keep the queue state for two queues. So, we need two pointers of each type. We need two indices and whatnot. And this basically gives you kind of buy one, get one 50% off sort of discount because we can amortize this 52-bit base address register for both queues. So we just need basically one additional ultraram block. So relatively efficient from the standpoint of actually fitting all of these onto the FPGA. So I'm going to be looking at implementing this hopefully in the next couple of weeks, so we can get everything updated and start playing around with it. All right, and then the other thing that I'm doing as part of this as well is reworking the queue control registers. And there's a couple of things I'm looking at here. One of them is placing the queue pointers in the same D word, so that'll, one, take up less address space, and two, we can read it atomically. More for debugging. This will make the QDEPs reported by MQNIC dump a little bit more usable. And then I'm also thinking about doing kind of having read-only registers, but then having commands you write. So like some of the MSBs will determine what the operation is, and then the LSBs could be an argument, something like that. So instead of writing to, as you would, a few bits in a larger register where you might have to do kind of a read, modify, write operation, or remember what values need to be written, things like that, which potentially have, performance and atomicity concerns. With this sort of a setup, you can just issue a bunch of writes, and it'll do the right thing. And this can also potentially support multiple operations at once, such as if you want to write a consumer pointer and rearm the CQ at the same time, we can have an opcode that supports that. Unlike now, where, maybe we can define a higher order bit, something like that, which you can write concurrently with writing the pointer. It's not as clean as, supporting some sort of a, operation setup. So that's one of the things I'm working on right now, is kind of defining what those operations are, what the encodings are going to be, and then getting that tested out in the HDL. The other thing that I've kind of started scratching my head over a little bit is potentially bringing in some sort of a soft core for configuration on the NIC side of things. Definitely been thinking about this on the board side of things. Haven't had time to get all the details fleshed out, but most of the drives that I've been looking at seem to have some sort of a command queue. Instead of having the NIC driver poke around at registers directly to set up base addresses and allocate queues and whatnot, instead, they'll have some sort of a processor, it seems, on the NIC, which handles this, and then software will communicate with that, through some sort of a mailbox or command queue setup. And this seems like it might be worth considering, because it potentially means that, you can kind of change out the hardware implementation without, having to make significant modifications to the driver, right? You can modify the firmware that's running on this little embedded processor, and it kind of gives you another sort of remapping layer. And so it could make things easier with the hardware driver versioning stuff. And it could also potentially help with some of the allocation components as well. So if you have something like, if you're running in kind of an SRIOV environment and you want to allocate queues on the virtual functions, well, if you're managing that in the hardware on the card itself, that's pretty straightforward, versus you might need to have some sort of communication back to the corresponding PF when a VF wants to allocate something, and then the PF has to hand it off to the VF and, send the necessary response back. So a few things that I'm still trying to get my head wrapped around at this point, but that's what I'm going to be working on over the next couple of weeks, hopefully. I think that about rounds it out for the status updates that I have for this week. Like I said, again, I haven't gotten a whole heck of a lot done because of, jury duty. So hopefully I'll have more to share at the next meeting. And then, we also have the Switch Dev meeting, where hopefully we'll hear a bit more about what's been going on there, especially since we missed one last week due to, well, jury duty. So at this point, if anyone has any questions or comments, fire away. Do I have any questions or comments from anybody? No? Okay. Carlos, do you want to present any updates about the switching related stuff that you've been working on, or do you want to save that for the Switch Dev meeting next week?
Okay, well, there's not many things to share with you guys since I think that it's 2 past weeks almost. Well, the only main things maybe is that the output key version of the Switch crossbar is already pushed into the repo. So we now have like 3 different implementations for the Switch crossbar.
Okay. And you have your test scripts, I think, right? So you can make some run some benchmarks, make some graphs or something based on those different setups. Okay.
Yeah, that's it. I have also updated the README so that you have some information about how to run the benchmarking tool. And this is what I want to do during this week, to have some results for the next Monday, just to see which kind of plots can be used to fairly compare the 3 implementations that we already have. For the next meeting, I think we should start discussing the main topics about the Switch, which are how we will be implementing the hierarchical version of the Switch, and also to see some aspects related to it, such as the root computation logic, that type of things. I think we should start looking more into the core of the implementation now that we have at least making some work around it.
All right, that sounds good. Well, looking forward to it. I guess that'll be on the agenda for the meeting next week. So whoever's interested, make sure to put it on your calendar.
Yeah, any help is more than welcome.
So maybe one bit from my side concerning the working contributions about enabling Verilog Ethernet and Corundum overall in the KR260 boards and Kria boards in general. So far I was testing things with a methodology that was kind of like inferred from the repo from Verilog Ethernet, which essentially entails testing things out externally, so not involving the PS. Now, if you want to involve the PS, then things get very funny because AMD designed the KR260 so that you need to ensure you configure within your bitstream all of the PS registers. If you do not include a PS block within your design, so if you just focus on building things for the PL and just leave the PS aside, which makes total sense in many designs, but if you do that, it's just not going to work. And the PS is going to go crazy. The PL is going to work out, but the PS is not going to work. For that to work, what you need to do is, even if isolated and not connected to anything, include at least the CU class, the single to scale class block, either manually or programmatically into the design while building things up. So there is a sync_ps tcl file that I think, Alex, you created manually. That does the job. Just bring that into your design, just a couple of lines added into the make file, and then instantiate that into, I think it's FPGA_core or maybe FPGA Verilog file, and then that does it. That does it because it does by default configure the registers, and then the PS will start working. This was not included in the pull request that I sent over, but there's a working branch in here that actually, and again, this is dirty because it was side testing. If necessary, I can rebase it and push it into the pull request, but that's there. Right now, the pull request is just focusing on essentially the corresponding changes to enable the KR260. So if you test out the pull request, just make sure you focus on just testing the PL. Don't try to log into the PS. It's just not going to work out. So be mindful about that. And yeah, that's one bit that's interesting. And yeah, our work on our side just continues progressing. We're not ready just to share and contribute back more stuff, but we will at some point. So yeah, thanks again for everyone or to everyone for the great contributions in across the repos. I know I asked in the past some weird stuff about integrating things with Corundum and the Linux networking stack. We kind of reorganized our thoughts a bit on that end. Ended up exploring and reviewing quite a bit the existing Linux driver, kernel driver that was implemented within Corundum, and that triggered quite a few interesting discussions internally. For now, we're just using DMA and DDR shared memory for quick testing. In the future, as we build up more layers of abstraction on top of UDP/IP offloaded into the PL, we may consider extending the existing driver to include capabilities, additional capabilities that allow you to configure the networking interface to either just do MAC offloading as it is right now, do MAC plus UDP plus IP offloading, maybe do MAC plus UDP plus IP plus maybe, I don't know, MQTT, if available also in the PL. That's something that we are considering in future extensions. However, the complexity of doing so is significant. I mean, you need to hack things around to connect the layers appropriately with the Linux networking stack, which is non-trivial because, as you guys may know, and as far as we reviewed it, at least, the LNS is not the simplest piece. So that was the confusion I had in the past. I was thinking that you guys, Alex particularly, that you had somehow figured things out and solved that already, which was the assumption I made. But since it's not, it might be something that we may contribute. And it may just fit. As I say, it's something we need to look up. I'm not making a commitment right now, but we have use cases wherein that could be useful. And I think the existing kernel driver seems to us, at least right now, a good starting point. But yeah, open to hear feedback or especially from those of you more experienced.
Well, it's definitely worthy of discussion, at least figuring out how the pieces might fit together and whatnot. So, as things are, progressing on your end, we can certainly discuss that in more detail. But yeah, getting back to the KR260, you said you guys mainly run Ubuntu on these things, right?
Right.
What is the process for, we're doing that with a custom FPGA image? Because unfortunately, using Ubuntu on these things doesn't seem to be very well documented. It's like, I know for Peta Linux, you bring the XSA over from Vivado, and then you drop that in the Peta Linux project, you build it, it gives you, your boot.bin or whatever, and a few other files that contain the FPGA image. But this thing, if you're going to use Ubuntu, how do you get the FPGA image loaded as part of the boot process? Do you do that before boot? Do you do it after boot? How do you do that?
There's a portfolio of portfolio. There's a number of ways you can go about this. And it also depends very much of which Ubuntu image you're using. So we should start with that. If you're using the official Ubuntu images, which are these ones, let me just give you guys a link. These ones. And I'm not positioning myself with this. I have my opinion about canonical Ubuntu, but I will not share it in here. But if you guys use those official images, what you'll figure out is that they have hacked the boot firmware to obscure a bit how things are happening, and it makes it a bit complicated to get your bitstream into the boot bin. Typically, that's what you want to do. It's not straightforward. You can do it, but it needs to be you need to do a bit of reversing and hacking in there. So doing things with this image is not that easy. One easy way around, if you want to make things work during boot, is to grab the root file system and then hack things around for what concerns the boot firmware. You can rebuild your own boot firmware, just change things and reuse the root file system. That's one way that works, and it's known to work as well. Now, if you don't care so much about loading the bitstream at boot time and you're fine just getting it during runtime, then there's, again, a number of reasons, a number of ways you can go forward. The simplest is using FPGA util. You just FPGA util -p, pass your bitstream, boom, you got it. There are some additional tools that build on top of something called libdfx, which stands for Dynamic Function Exchange. It's the new fancy renaming of partial reconfiguration. This is kernel library, so it has kernel modules which in a nutshell gives you user space tooling and allows you to, in a way, change your bitstream dynamically during runtime in the same way, in a similar way that that other tools do it, like FPGA util, but relying on this libdfx infrastructure. And so the user space tooling for that would be xmutil. And so you can xmutil, for example, xmutil list apps is a command that would give you kind of like the current overlays installed. And in the simplest setup, you would have just one overlay and one single slot. In more complex like constructs, you can have multiple slots, and with libdfx and xmutil configure and load and unload each one of those various slots. For
So
libdfx.
do you have to use, libdfx when your design is set up for PR? I mean,
No.
and if the design is not set up for PR, then it doesn't work, or?
No, you don't need to design anything for PR or with PR in mind for libdfx to work. Like you can just do your design and then use libdfx or xmutil, which is the user space tooling.
Okay, okay.
And
So even though it is called DFX, it works if you're just reconfiguring the whole FPGA.
Exactly. That's the thing. If you're reconfiguring the whole FPGA, if you, however, use PR, then you need to pass some metadata to libdfx to make sure that you are doing things right. And that's where things start getting funny, but I think that's beyond the scope of this discussion. For the sake of what we are doing in here, I would recommend to use FPGA util. FPGA util -b, just pass the .bit file. That's it.
So I guess the other aspect too is it's one thing to load the FPGA configuration, but you also have to have, I think, a device tree overlay that will actually allow the drivers to be attached.
That is with libdfx. With libdfx, you are required to provide a DTBO.
Okay. So in that sense, that's probably a better path because it'll manage both the FPGA image and the corresponding device tree.
Right. Whereas with FPGA util, you don't necessarily need to pass a device tree over.
Can it handle that, or?
I'm not sure.
You have to do that
I think there are some flags. I think there are some flags that might get you in the right place. I certainly know that with libdfx and with xmutil, you are required to provide such a thing. So you need to construct not only your bitstream. Typically, actually, it does require you to provide not the bitstream in raw, but the containerized XCL bin, I think it's called. And then besides that, you need to pass some JSON and DTBO files, which allow you to modify your device tree and load and unload these slots dynamically. So that is a way to move forward when we need to do so. Either we build the corresponding app, if you want to call it that way, meant for xmutil and libdfx, or we just load manually first the bitstream and then modify the device tree manually as well.
Okay. And then I guess there's another question I had about how the PLLs work from the PS side. So I think by default, it gives you like two 100 megahertz clocks. But if I want like a 250 or 300 megahertz clock, will that get updated as part of loading the FPGA configuration? Or does that have to be poked at somehow if we're doing runtime reconfiguration, right? Instead of trying to hack the bootloader. Is there a way of changing the PLLs, or does that get done as part of the process of loading the bitstream, or does it make sense just to consider the clocks from the from the PS as being fixed, and then drop a PLL down on the FPGA side of things?
To be honest, I don't know for sure. I would need to test it. My guess is that if you reprogram the whole PL, the whole FPGA, I think chances are that you may get it right. But I am just speaking out of memory in past projects. I would need to test it to be sure.
Well, I guess that raises another point: is that does the configuration that you set for the PS have to exactly match what Xilinx has done in their image, right? For all of the peripherals on the board and whatnot. all the
Oh.
MIO settings so it's like if that doesn't match and you load it, does that cause the whole thing to crash? I mean, that
Well,
would be
that
problematic.
is
So
that is an interesting question, and it's somewhat related to what I was sharing concerning, right, the fact that if you do not configure the PS at all in your design, like in your bitstream, then things will just crash right away. So I think we can extrapolate from that you misconfigure PS registers within your bitstream. Then chances are that you may get similar issues. But that's just a guess, Alex. But I would say so, to be honest. I think the safest path right now, based on the many limitations that exist in this board, is just to make sure that within your design, you just include the corresponding CU plus block at least, which you can
Right.
very easily just export to a TCL file as you do have it. I know the one that you have is generic, meant for CU plus designs.
Well, so the ones that I have, it's specific to each board. There are, some modifications in there to match whatever board it's running on. So yeah,
Okay.
for the ZC102, ZC106, I had to make some adjustments based on which peripherals were present and whatnot.
Okay.
What I ended up doing for the KR260 is I found the Xilinx board files for that, which has a bunch of settings for the Zinc, for the PS side. They seem to have like two different files that I guess get merged at some level for that. So I basically kind of pulled their XML and manually massaged that into a TCL script, which I think should set everything up correctly. But yeah, that's what I was trying to figure out. It's like, okay, well, how do we even load this thing on here without, I know how to do that at boot, right? If you get it into the bootloader, but I don't know how it works at runtime, especially if you're poking at settings there. It seems like that could cause a lot of unintended side effects if it's not done exactly right. So,
yeah, that makes sense. I mean, if it helps, one of the things we are doing is we know there's a path to programmatically, I guess, look into existing files and map things, like the XML path you're describing, if I can call it that way. One way we discovered that's turning out to be handy is, though we tend to dislike using the GUIs, it actually proves to be quite useful to bring up Vivado, open up the design, like literally one of the designs we built out of Ethernet Verilog, open the block designer, and over there just bring in the PS and then configure whatever you need to right away, and then export the corresponding block design as a TCL script. And that so far is turning out to be pretty useful for us because it sets the PS exactly as we need it, and it does it once we reconfigure the PL. Once we use the corresponding output bitstream out of it. So far that is working on. That sounds to me like a way forward, but yeah, I guess lots of possibilities in here. Complex devices.
Just out of curiosity, how are you guys loading that design on the board? Are you using JTAG? Are you booting into Ubuntu and using the FPGA tool or
FPGA util? Yeah, FPGA util.
FPGA util, right? Okay.
Just grab the bitstream, just pass it at runtime. It's working out. It's configuring the PS and the PL as we want to. If you want to quickly prototype, we are being increasingly recommended to use Pink. This is coming from official sources.
Ping.
And Pink, it's a framework. We are not very familiar with it. We're just learning about it because clients are asking us to do so. It's a framework. It's kind of like Python-like abstractions of lower level abstractions. Like it does abstract away XRT, the Xilinx runtime, and various other libraries that AMD and Xilinx has been created. So with Pink, you have various primitives to also run and load overlays or bitstreams directly. It boils down to actually just instantiate a class passing as an argument the corresponding bitstream, and it just does it for you. So one line in Python does it all.
So do you have a link to this thing? Because you put ping into Google, you don't get anything useful.
I
Well, I mean, I guess you get stuff that's useful, but not relevant.
You need
Or
to
some
know
other
to write it
search
with a
term.
Y.
right. So you may want
Oh,
to
you mean it's pink? Is that
Yeah.
after the zinc board thing? Okay.
yeah. I mean, you just know my pronunciation is probably horrible since I'm a foreigner, but that's how I would pronounce it. Pink. Sorry.
Okay. All right. Well, but I thought that was they have a dev board or something, but this is more than just a dev board.
Right. That is actually, I have the dev board somewhere here, and I had it for a few years. But my understanding is that this has evolved from just a dev board to an actually whole community. Like right now, according to what I'm being told, this is one of the biggest communities for FPGA, like addicts or folks.
Okay. I mean, I'm only familiar with the board, just kind of in passing, but okay, I guess there's more to it than I thought.
I mean, as I was saying, I'm also new to this. I can confirm it works, meaning that like a simple 5-10 line Python script gets your bitstream loaded, and then you can play around with the PL, doing memory allocation, configuring registers, everything in Python, like sort of like syntax, which is cool if you're kind of like scripting things for prototyping purposes. So it turns out to be handy and useful, especially when you combine it with Scapy and Coco TV. It gives you a bit of a flexible sort of like tooling. But as I said, I can't really recommend it right now. I'm just
You're starting to play around with it. Gotcha.
Yeah, and to be honest, so far what I've looked into is that this is just an abstraction on top of other tools such as XRT, the Silence runtime. And frankly speaking, for performance reasons, we are just using this for prototyping, but then killing it and relying directly on the C++ APIs of XRT. So, yeah.
Interesting. All right. Well, I guess I'll take a look at that as well. Perhaps. But yeah, good point about that FPGA utility for loading the bitstream. I'll do some playing around with that. It's just that a lot of the stuff doesn't seem to be very well documented in any kind of organized way. So it's just like anyway.
Fully agree. Yeah, the documentation is certainly one of the missing pieces, I guess. I don't know if I can say in all hardware companies, but I tend to get quite a bit the same from Microchip, Intel, NVIDIA, and so on and so forth. So, yep.
The other annoying thing.
Well, I would say that regularly Xilinx has one of the best documentation, at least for the hardware, for the chips.
Yes, on the FPGA side, it's pretty good. We're talking about the software side.
Yeah, tooling is interesting, and software side is worse. Yeah, that's right.
I mean, nicely put. There was this side conversation with an executive in AMD, which I will not name, but I can tell you that it was a very fun kind of like over a beer conversation wherein we were sharing impressions about the readiness of hardware companies, meaning Intel and Xilinx and AMD, about modern software engineering. And this person acknowledged that modern software engineering is still foreign to many of these companies and groups. So yeah, I think that's there.
I just wanted to add a comment to your earlier discussion. I just couldn't reply to about how to set up clocks dynamically when running or dynamically loading, reloading partial portions of the FPGA. I would say if you're using this device tree overlay setup, then your overlay driver should be able to request changes of clocks when laid out properly. So Xilinx does support the clock management framework provided by the Linux kernel. So if you describe the hardware correctly, then you could also request changes of clocks dynamically. That should be fully supported. We never used it, actually, not partially, but I know sometime at, I don't know, 2017 or something, so with Vivado 2017 and so on, they changed a lot of the infrastructure within the kernel drivers. So they should be fully supporting this clock framework.
Okay, so basically you load the bit file basically into the FPGA side, and that may or may not touch registers on the SoC side, and then you load the device tree overlay, and that should reconfigure the PLLs on the SoC side.
Yes. So
drive it to
basically, the
FPGA
idea
side.
is
Okay.
that the driver structure can reflect the clock structure. And if you have interfaces that's saying like, okay, whatever I'm controlling is connected to this clock, then you can request a specific frequency from this clock. I guess that's the idea about this clock framework that has been put in place because all these complex SOCs were arising with a lot of different clock domains. And yeah, yes, that was the basic idea, and Xilinx at some point jumped onto this.
Right. Yeah. I mean, I've definitely seen that for doing the board level configuration, right? If you have the SI 570s or whatever, but because I've been bitten by that in the past when those are running at the wrong frequency. But yeah, I guess that would make sense that it extends to the on-chip PLLs as well.
Yeah, +1. Thank you, Ulrich. And that makes sense. Totally. Like if you configure things appropriately on the PL in your bitstream, and then the corresponding device tree overlay sets up the PS clocks appropriately, then the kernel should pick it up and then go forward with it.
So I guess then there's another question is, how do you get the device tree overlay? Does Vivado generate that as part of the XSA thing, or do you have to make that manually, or?
That's about it. At least to my knowledge, which is I think very limited on that end, but I'm just hacking things around manually. It would be lovely for Vivado to generate device tree overlay.
Yeah, I also don't know about some automated way, but the last time we used it, and it's quite a long time ago, we did everything manually. And I guess back that time, FPGA util was almost not supported upstream by Xilinx, because initially all the subsystem in the kernel has been developed by Intel people. And a nice Atos guy ported it to Xilinx devices because they use that in their USRPs.
Gotcha. Ugh. Not a big fan of the device tree either. Such a pain. It'd be nice if the chips worked a little bit closer to something like PCIe, where you could just enumerate what was there. The device tree is just a binary version of a header file.
Yeah, that dynamic behavior in a way is something we're trying to push into the robotics world. Not sure if it's gonna work out dynamically, to be frank. We may end up in something like device trees. Not precisely that, but something just conceptually similar. But I am with you. I wish this can be determined dynamically.
I mean, I guess when it gets down to it, I don't even know how, kind of a normal PC handles that for a lot of the internal stuff. It could boil down to, some firmware having some header file in it, basically, that gets exposed somehow to the operating system that's running. So, because I know just a normal desktop machine doesn't use device tree. So how does the OS
I guess that's
on there know
where they come from, right? So they came from header files, and at some point the Linux people said, okay, we can't keep header files for every board that's out there, so we need to do something that's loaded dynamically.
Right, but I guess it's a question of, where that thing lives, right? It's the device tree. It's not burned into the silicon. You have to load it separately, along with the operating system in most cases. I guess in some cases it is provided by the bootloader, but that's still burned into, flash or something. It's not physically part of the SoC. Anyway,
yeah,
I'll play around.
That layer of self description of the hardware is not reached yet.
Yeah. Like that's one of the biggest advantages of something like PCI Express is that, you know, you can enumerate it and you can see exactly what's there. And then you can load, you know, the corresponding drivers and whatnot. Even if you're just talking about integrated components. I know for a lot of you know, Intel CPUs and whatnot, they'll list like 50 integrated endpoints via PCI Express, all with their own device ID and whatnot. So yeah, that makes things a lot easier from a driver perspective. Is that it's just all there. You just you know, you can load the right one pretty easily because you can enumerate the whole thing. But not so much on SoCs, which is highly annoying. Without that device tree, you're hosed. Anyway, I'm gonna play around with this KR260 more, hopefully soon. I figured I would see if I could get stuff running on there. If I could, I would get that committed. If I ran into some major roadblocks, then, you know, work on it a little bit later. But yeah, it's good to hear it's not some pre-production board that has some, you know, weird pre-production board issues. It has some weird issues, but I guess
No, yeah,
they haven't been fixed on a newer revision.
yeah, we were all concerned about that. So no, I just went ahead and purchased a new one. It was it sounded like the simplest path
Right.
forward. So that's what we did. And no, I can confirm the other board we got works.
Okay.
Works
Oh, I guess one of the things I should mention too is I know there was some head scratching over voltage levels and whatnot, but these things actually have some IO banks to support 3.3 volts. I always forget about that. And those pins are wired to the 3.3 volt banks. So no voltage issues. That's fine. I think that the Zinc and maybe also the Kintex parts support that, but none of the Vertex ones do. They're all like 1.8 volts or 2.5 volts max on all of the IO banks. So anyway, I don't think there's anything else interesting to report about that. But yeah, I did finally get the newer Ubuntu image booting. I didn't try the old one, and I also have not tried uploading or updating the boot firmware on there. I guess I can try that now that I actually have it booting. I just got to remember close out of Avado completely, and then it'll work. I guess the flip side is I can't watch it boot, right? Because this JTAG and the serial port are through the same USB connector. So if I unplug it, I just gotta hope it's working.
Yeah, I mean, if my recommendation is if you just want to test out the PL and you want to flash it using JTAG, you can do so using Vivado in the usual way. And
right, I'm sure that'll work. But the problem is with if I want to test Corundum, you know, I kind of need to have the both of them running. So I got a loaded driver on there too, and so on and so forth. So I basically with this thing, I sat down with Peta Linux. I'm like, crap, I don't know how to create a Peta Linux project and set everything up correctly for this board. So I'm like, yeah, okay, we'll try Ubuntu. Then I'm like, okay, I don't know how this is supposed to work either. Cool.
No, as I was saying, for that other use case, what I would recommend is just to use this branch I passed over, which includes the modifications required to essentially produce the bitstream and then load it from the PS, while still remaining operational. And then the modifications introduced in there is the fact that the sync PS is also part of the design, and thereby the registers will get configured appropriately.
Okay, gotcha. Yeah, I'm just opening up those links because as soon as I quit out of this meeting, they're going to be gone. Okay. Cool. Yeah, I think I got all those here. So we got the Korea pink thing, and then
yeah, ping me if you want to discuss this offline. For testing things from a very low Ethernet perspective, the pull request should do. If you want to test Corundum, then happy to walk you through it, or maybe just organize an offline hacking session. We can do it together.
right, yeah. Yeah, okay. Well, I'll do some chipping away at that myself and see what I can accomplish. And if I can't figure it out, then yeah, I'll contact you. But yeah, I think if with the Ubuntu image, you can install a compiler and whatnot and build kernel modules directly on the device, right? So yeah, okay. That shouldn't be a big deal. The other thing I noticed that it was trying to net boot, so I was trying to figure if maybe net booting would be a good option as well. until I had the SD card image set up correctly.
does work very well. There's actually pretty fancy stuff you can do with it. And you can introduce even security as part of that if you have multiple boards and kind of like is required by your application. So yeah, it works pretty well.
Yeah. All right. Let's see. So is there anything else that we need to discuss for today, or anyone else have any other questions or comments or anything?
Yeah, I just kind of went through what you discussed today, and there's one thing coming up to my mind. You mentioned that earlier that the Intel bug with the MLab, what is it, the read enable
Yeah.
inference, and you mentioned like that it does only affect FIFOs. I wouldn't think so. But on the other hand, all the code in there in Corundum is written in a way that the Quartos tools don't infer MLabs from this little memories. So that's one of the patch sets that we provided once. I guess you never made to really review them
All
to
right, I guess we'll
actually
take another look
make
at that.
this infer. Yeah, I'm just walking home, so I can't give you a link,
Yeah,
but I
I
can
will
just
take a look at
ping you.
at the output of Quartus again, because I seem to remember it is using at least some. It wasn't. I don't think it was just the FIFOs that were ending up in MLabs. There was some.
Yeah,
other stuff
possibly there are
around.
some MLabs inferred, but at least 1 year ago, I guess, that's when we discussed this or started discussing this. There was a lot of logic in the queue managers that hasn't been inferred into MLabs, and we worked on this one to squeeze it into MLabs, and yeah.
Okay. Well,
Not
I am going to
sure,
be
so-
doing a pass over the. I am going to be basically completely rewriting the queue managers, and I think some of the code there is going to be going away.
Okay. Yeah.
So that's probably one of the reasons I'm like, well, I guess we could make modifications to this, but it's the that I think it's that operation table probably that would make sense to put into MLabs, but that's one of the main things that I'm going to be getting rid of.
Okay.
That is going to be handled, differently with the new setup.
Yes. Yeah. That's
But so
good for
the
us.
one thing that I was
Just wanted
thinking
to
of is
mention
that it
this.
might have to do with kind of the semantics for how these things are read, right? Because with the FIFOs, we're using a pretty explicit read enable, whereas I think in a lot of other cases there might not be a read enable; it's just continuously being read, and as a result, it doesn't have a problem with that because it doesn't have the read enable. So that could be what's going on. Like if some of these other RAMs do have read enables, then it might be an issue.
Yes. Yeah.
But it's like if this is a problem, that you should be seeing, strange behavior. If one of these memories is, if you're reading the wrong thing out of it, we should be seeing hangs or crashes or data corruption or something. But in all of my testing, the only thing that I've seen is some of this checksum related stuff, and then also I guess some lost events, which I think was in part related to this issue as well. So anyway, I've gone ahead and implemented that workaround in the code base for the Intel devices, which I think will work well enough until Intel actually fixes the tools, which who knows when that'll happen.
Yes, we'll see.
Yeah, they said it was scheduled for a future release, but they've gone through, I think, several releases between posting that and now. So
yep.
I think I tested 22.4, I think was the latest one of 22, and then 23.1, and they're both have the same problems. So
okay.
Anyway,
yep. I guess we had a discussion once about if you're rewriting portions of this path. I think at one point we added some interface from the I don't recall the name, but
to the scheduler?
Right, exactly, that it can report back the amount of data that has been fetched for a specific queue. Are you
Right.
going to integrate something
Basically do
like
kind
this?
of an early report or something. I probably should. I'll take a closer look at that. Yeah. As I'm working on this and see if there's you know, an obvious way of doing that. But yeah, I'll take a look at that.
Okay, cool.
Because if I'm rewriting a bunch of stuff, that would probably be a good thing to get squared away as well. Yeah. Thanks for
Yeah, I
reminding
guess
me about that.
Yeah, no problem. It just came to my mind, and I guess the last time when we discussed about this, it was kind of exactly the same conclusion. Let's revisit this when we rewrite more code.
Right. All right. All right. So are there any other topics that we need to discuss, or is that pretty much cover everything?
Nothing popped up anymore.
Nothing popped up. Okay. Sounds good. I guess we'll see you guys at the developer meeting in 2 weeks, or maybe in a week if you're interested in the Switch stuff.
So,
Yes,
Thanks, everyone.
looking forward to it.
All right. Sounds good. Talk to you guys later.
See you
bye-bye.
guys.
Thanks, goodbye.
Bye.
Talk to you.